For example 13, we see that we have the figure showing the velocity of a body moving along the line. Alright, so this is velocity is a function of time. So we have our velocity, our v-axis, and we have our time axis. And the first question asks, when does the particle move forward? So a particle is moving forward when the particle has positive velocity. So we can see that the positive velocity is when the velocity function is above the x-axis. So we can say the particle moves forward from t equals 0 to 2. And I'm going to use interval notation here. All right, so 0 to 2. So notice that's not the point over 0 up 2. This is from t equals 0 to t equals 2. This is the same thing as writing t is between 0 and 2. You can write it either way. Okay. And not only is it moving forward from 0 to 2, but also from 7 to 10. So that's our second answer as well. All right, 7 to 10. 0 to 2 and 7 to 10. When is the particle moving backwards? Well, particle moves backwards when it has negative velocity. And the negative velocity is occurring when the graph is below the x-axis, or the t-axis in this case, which is going to be from 2 until 7. We also are interested when the particle is going to speed up and slow down. This is a little trickier. I'm going to come back to that in a few minutes. Let's move to B, because this picks up where part A left off. When does the body reverse direction? Well, think about it. The particle is moving forward here because it has positive velocity. Then the particle moves backwards from here to here. So at this point, when t is 2, right before that the particle is moving forward. Now the particle is moving backwards. So therefore, the particle reverse direction, the body reverse direction at t equals 2. When we see the velocity change sign. Right? So not only does it happen at 2, but it also happens at 7. Right? So t equals 2 and also 7. Why? Because velocity changed sign. Okay. And then when is the body moving at a constant speed? Okay, when the body's moving at a constant speed, when we see the word constant right there. So you want to take a guess as to where this is going to happen? That's correct. It's where our graph has basically a horizontal tangent line for a while there, and that's going to happen from 3 until 6. All right. So from the 3-second mark to the 6-second mark, that's where our body's going to have constant speed, again, because we are not seeing any change in our velocity. Okay, the velocity's change, which is the tangent line, has a slope of 0. There's no change in the velocity. Let's go back quickly to speeding up and slowing down. So again, a particle speeds up, speed increases. That's what's happening when we're speeding up. The speed increases when velocity and acceleration have the same sign. Okay, so remember, velocity we know is positive when it is above the t-axis, and velocity is negative when it is below the t-axis. All right. So velocity, let's just write that down. Velocity is greater than 0 when it's above, so that's going to be from 0 to 2, and also from 7 to 10. Those are the two intervals in which velocity is positive and velocity is negative. All right, velocity is less than 0 between 2 and 7. That's this area down here. Okay, so we're just writing that down because now we also want to check out when is our acceleration positive, when is our acceleration negative. Okay, those are key things as well, because now we can determine what's going on. When they have the same sign, we know that our particle is speeding up. Okay, so what's going on here? Well, acceleration is the derivative of velocity. Acceleration is the slope of the tangent line. So let's look at our slopes. At this spot right here, and anywhere in this spot, we have a positive slope. So acceleration is increasing or positive from 0 until this point right here, which is when t is equal to 1. So acceleration is positive from 0 to 1, and we know that because we see a positive slope. Where else do we see a positive slope? Yeah, over here, from 6 all the way to 8. Any point on this line, if we were to draw a tangent line, we would have a positive slope on our tangent line. So from 6 to 8, that's the other spot where acceleration is positive. Okay. Now let's look at when acceleration is negative. Acceleration is negative means that we have negative slopes for our tangent lines. So that's going to happen here, and here, and here, and anywhere on this line segment right here, which begins at 1 and ends at 3. So from 1 to 3, acceleration is negative. Acceleration is also negative in this part right here, and that goes from 8 until 10. So those are our two intervals where acceleration is negative. Now our particle speeds up when acceleration and velocity have the same sign. Well, from 0 to 1, acceleration is positive, and from 0 to 1, velocity is also positive. Actually, from 0 to 2, but from 1 to 2, even though velocity is still positive, acceleration no longer is. So from 0 to 1, that's going to be one area of time where our particle is speeding up. Well, particles also has positive acceleration from 6 to 8, and then positive velocity from 7 to 10. So from 7 to 8 is the other time when the particle is speeding up, because both acceleration and velocity are positive from 7 to 8 and from 7 to 8. But we also have to check out when acceleration and velocity are both negative. Well, velocity is negative from 2 to 7. Acceleration is negative from 1 to 3 and 8 to 10. In that short spot from 2 to 3, acceleration and velocity are going to both be negative. So there's one more part where the particle is speeding up, and that's 2 to 3. Now we want to know when the particle is slowing down. Particle is slowing down when they have opposite signs. So acceleration is, let's look at this positive velocity, negative acceleration connection. That would be opposite signs. Well, from 1 to 3, 0 to 2, so if we combine these two, we see, or intersect them rather, we see that from 1 to 2, velocity will be positive, acceleration will be negative. So 1 to 2, and then also from, if we look here as well, from 7 to, from 8 to 10, that will happen as well. So from 1 to 2, and also 8 to 10. If we look at the connection in the other way, where the intersection, we have 6 to 8 and 2 to 7. So we have to, 7's our end point. So if we go from 6 until 7, 6 to 8, the acceleration is positive, but 6 to 7, the acceleration is still positive. And over here, 6 to 7, really 2 to 7, but we can cut it as 6 to 7, velocity is negative. So 6 to 7 is our final spot where it's slowing down. All right, let's look at this from the graph. Instead of doing the crisscross here, let's look at it this way. Look at our answers. 0 to 1, 7 to 8, and 2 to 3. That's when our particle is speeding up. Here's 0 to 1. Here's 7 to 8. And then here's 2 to 3. Kind of darken those three spots. 0 to 1, 7 to 8, 2 to 3. In those three spots, we are positive with positive slope, or we are negative with negative slope. Okay? When we see positive graph, positive slope, here and here, or negative graph, negative slope, then we are speeding up. We are slowing down when the opposite happens. 1 to 2, so that's this region right here. And also 6 to 7, that's this region right here. And finally 8 to 10, that's this region right here. In those wider regions, what happened? Positive function, negative slope. Positive function, negative slope. Negative function, positive slope. So our slope does not match the function. The sign of the slope does not match the sign of the function, and therefore we are slowing down.